slower today. So bear with me, but you need to obviously go slower because you were so lost yesterday. So standard form of a quadratic. First of all, what makes something quadratic? It's degree what? Degree 2. Quadratics always have a certain shape. What shape is that?
U-shape.
A U-shape. Is everybody familiar with that?
Yeah.
Okay. So those U-shapes have a minimum value or a maximum value, right? Well, quadratics have this form, ax squared plus bx plus c. Now I'm going to tell you once again, this is the standard form of a quadratic. That's important. This is the standard form of a quadratic, ax squared plus bx plus c. Now understand something. It is important that you understand a is always in front of x squared. Is everybody okay with that? A is the coefficient, the number in front of x squared. B is always, always, always in front of x. So B is in front of x. It's the number, the coefficient in front of x. And C is always, always, always our constant coefficient, meaning there's no variable with it. So A, B, C. Are we all okay with that? Okay. You're going to tell me, what is A, B, and C in each of these quadratic equations? What's A?
2.
What's B?
3.
And what's C?
1.
Okay, what's A?
2. -2.
-2. What's B?
-3.
And C?
-5.
Okay. What's A?
1.
What's B?
2.
What's C?
0.
Good. Questions? What's A?
2.
What's B?
0.
And C is?
-7.
Okay, good. So we're getting that a little bit better hopefully today. Okay, so now also, this is what you really didn't understand yesterday. Okay, so we should definitely have know how to do stuff like this back clear back in secondary math 1. So guys, if this is our function, f of x is equal to x squared minus 2x minus 3. Remember, f of x just means y, right? So technically, f of x and y are the same thing. This is just saying we have a function of x. You're going to see that notation a lot more in secondary math 2. So f of x means we have a function of x. Is everybody okay with that? But really, f of x is the same thing as y. So y is equal to x squared minus 2x minus 3. This and this are the exact same thing. F of x means we have a function of x. Y means we have a function of x. Okay, so now if I said to you, I want to know what the function is at certain x values. So, I want to know what our function is at -1. Look, x is -1. If you want to know what your function is at -1, you're plugging in -1 for x. So we're finding our function at -1. So if we want to know our y value at -1, we're plugging in -1 into our function, and that's going to give us our y value. Does everybody understand? Let's look. So instead of f of x, I'm going to use y. So we know that f of x is y. So we have y is equal to it. If I want to know what y is at a value, so at -1, we plug in -1 into the function. Whenever you substitute or plug something in, you have to use parentheses where you substituted. So because I'm plugging in -1 squared, I've got to put parentheses. So -1 squared minus 2, we're timesing by -1. Minus 3. Now look, isn't all that going to just become numbers? And isn't that going to be y is equal to some number? So our function at -1 is going to be this. So our y value at -1 is going to be whatever we get. So we calculate it. -1 squared. You have to get better at plugging these in with parentheses in your calculator as well. You guys have got to just be more advanced than kind of how we've been kind of acting like. You've got to be precise in typing things into your calculators, so parentheses are necessary. How I wrote it is how you need to type it in. So practice typing it in. So if I said to you, what's my function at 1? You'll plug in a 1 wherever there's an x. So we're going to be doing 1 squared minus 2 times 1 minus 3. So 1 squared is 1. -2 times 1 is -2 minus 3. Type it in your calculator. 1 minus 2 minus 3. You get -4. So our y value when we are at x equals 1 is -4. So guys, this is input versus output. So everybody look up here for a second. This is what we put into our function, right? Right? Isn't this what we put into our function? This is what we get out, right? When we plug this in, is this what we got out? Out of plugging that in? When we plugged in 1, is this what we got out? Yes. So input versus output. So what you plug in is what you're going to get. You're going to get some number out. So just keep that in mind. All right. Do 2 for me, quickly. Did you all get -3?
Yeah, I just realized what I did wrong.
Okay, so when we plug in 2 into our function, we get -3. Now everybody look up here. So now we have a bunch of points. I should have made us do this by hand instead of just cheating and using our calculator all along. So insert picture. So now I'm going to graph those points. So I'm graphing those points. So I'm going to graph them. So I go to -1 up 0. I go over 0 down 3. I go over 1 down 1, 2, 3, 4. And I go over 2 down 1, 2, 3. Now can you see we know it's quadratic, right? Can you see our quadratic forming here? So you see how like these XY points work. Now I've been letting this kind of cheat because I've been letting you get the XY points by using your calculator and not having to calculate it, but then you weren't because I did that, I hurt you because you weren't understanding where you're getting those from. Do you understand now where the XY points come from? Okay. So I could draw in my parabola. Okay. Questions on that? Okay. Just making sure. Okay, so next thing to know, this is what we learned yesterday. We learned how to graph a quadratic in standard form. That was the big thing we learned yesterday, how to graph a quadratic in standard form. I gave you these 4 steps. Now guys, if I give you step-by-step instructions, you need to take notes on it and then follow them step by step and then just graph it. So here we go. The first step to graphing a quadratic in standard form is find the axis of symmetry. And the axis of symmetry is this formula, x equals the opposite of b all over 2a. 2a means 2 times a. Is everybody comfortable with that? Okay, second step. Once you have plotted the axis of symmetry, we know the vertex is going to fall on that x value on the axis of symmetry. You're going to find your vertex. So if you know that your x value is 2, can't you find your y value by just plugging it into your function just like we did?
Yes.
Yes, so we'll find our vertex. Then our third step is find the Y-intercept. That means where it's crossing the y-axis. So if it's crossing the y-axis at 0, at x is equal to 0. A Y-intercept is always going to cross at x is equal to 0. Because it hasn't moved anywhere on the x-axis, right? It's crossing on the y-axis somewhere. So does that make sense why we can always plug in x is equal to 0? That's true for even non-quadratic functions.
That's where I was getting confused.
Yeah, so good. I'm glad that we're re-going over this. That's why we were spending today, because a lot of people were. Okay, and then fourth, I need you to find 2 other points. Now today, because I'm giving you a whole nother day, I want you to find 2 other points by hand. So I'm going to look for work. So I'm going to have you plug them. I'm going to have you pick 2 other points. So you're going to say, I'm going to plug in 3, and you're going to plug it in, and then graph it. Does that make sense, everybody? That's what I want to see from you today. I required all my classes in the past to do that, but I kind of was like, I'm just going to show them the easy way, but it was a good lesson learner for me, because the easy way is not always the best way, because then sometimes people don't really know where things are coming from. Okay, here we go. I'm going to do number 10 with you on your worksheet. Get it out. Hopefully today it will help make more sense. So our first step to graphing a quadratic is to find the axis of symmetry. That's the formula. X equals -b over 2a. We're all good with that, right? So we know what a is. A is, b is, and c is questions. So we're just plugging it in. Now remember, I like to say this formula, the opposite of b over 2a. So the opposite of b, because -b technically means the opposite of b. So the opposite of b would be +2. Questions on that? Divided by 2 times a. 2 times 1. Now, I'm multiplying by 1, right?
Yep.
So what we have here is 2 divided by 2, which is 1. Now look, our formula says x is equal to 1. So I'm going to write that. X is equal to 1. That's my axis of symmetry. I draw that in. So we know we're going to have a parabola that is symmetric on that axis of symmetry. I saw a lot of people in here not drawing their parabolas symmetric on this new dotted line. But our parabolas, we know, are symmetric around the axis of symmetry. Okay, second step here, find the vertex. Well, guys, the vertex is going to fall on that axis of symmetry. It's going to be either here, 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 somewhere on this line, right? So it's going to be somewhere on that x value, right? So it's going to be at x is equal to 1 comma question mark. X comma y, right? Because a vertex is an xy point. Is it making more sense today? Second time seeing it.
Yes.
Okay. So if we want to know that y value at this x value, don't we just plug that value into our function? Okay, so we're going to plug it in. 1 squared into the function, right? 1 squared minus 2 times 1, plugging it in for x, minus 1. Let's all practice typing it into your calculator. Don't rely on your neighbor. What do you get? So that's equal to -2. Did anybody get something different? Do I need to come help you out real quick? Okay, so we got y is equal to -2. We plugged in 1, we got -2. So 1 comma -2. So our vertex is at 1 comma -2. So I'm going to plot my vertex. Over 1, down 1, 2. I plot my vertex. Is this a minimum or maximum? Why do you, you're right. Why do you say minimum? It's a what? How do you know it's the lowest? What if my parabola goes like this? Well, it will be, but even you're right. You're on the right track. So even, but what? Couldn't I draw parabola downwards like that? So then what? So A is what? You're on. There you go. That's what I'm looking for. So A is what? Positive. So we know it's a smiley face, right? So it's definitely a minimum. Very good. All right. So now we're to our third step. Find the Y-intercept, guys. The Y-intercept. So here's our Y-axis. So once again, so that you understand what you're doing, it's going to cross this Y-axis somewhere. We don't know where, but we do know it's at the X value of 0, right? So we're going to find our Y-intercept by saying X is equal to 0. So if we want to know where our function is at 0, where's the function at 0? We plug it in to our equation. 0 squared minus 2 times 0 minus 1. And what do we get? -1. So we have the Y-intercept at -1. So I like to write it as a point. 0 comma -1. So we go over 0, down 1. Now look, isn't it crossing the Y-axis at -1?
Yes.
Okay, now I want you to find 2 other points. We're going to pick 2 other X values to find the Y value for. So 2 and what? 2 and 5, that's fine with me. Let's find the function at 2. Everybody plug it in. So function at 2, you're plugging it into your equation. 2 squared minus 2 times 2, right? Minus 1. Everybody should be practicing typing it in. -1. Does anybody need help typing that in? Did we all get -1? Okay, 5. Let's plug in 5. So 5 squared minus 2 times 5 minus 1. You get 14. So I'm going to plot those 2 other points. So I'm going over 2, down 1. And then I'm going over 5, up 14. So over 5, up 14. Now guys, isn't that going to be symmetric? So can we draw in this side? It's going to be, this parabola is going to be symmetric on this red dotted line here. So look, if that point is at 14 and it's over 1, 2, 3, 4 from the axis of symmetry, we're going to go 4 this way from the axis of symmetry. So 1, 2, 3, 4. You guys see how I did that?
Yes.
Okay. Because a lot of people were drawing their parabolas not symmetric. They were doing it on the y-axis, but if it's shifted, your axis of symmetry, you've got to go off of the axis of symmetry. Is everybody good with that? Okay. You're all good. So do I need to do another example? No. Yes or no? Raise your hand if you'd like one more. Okay. Then I won't do another one. Okay. Number 7. Here we go. We're going to do this one. Off the worksheet. It says, Read the directions. It says find the equation of the axis of symmetry and the coordinates of the vertex of the graph of each function. So we're just finding the axis of symmetry and the vertex. So I'm doing number 7 with you off the worksheet. So we're given the quadratic y equals 2x squared plus x minus 14. We want to know what's the axis of symmetry. So we know the formula for that is x is equal to negative b over 2a. So a is equal to 2, b is equal to, and c is equal to. So now we're just plugging it in. So x is equal to the opposite of b, which is negative 1 over 2 times a. A is, so if you simplify that, on top we have a negative 1, on bottom we have a 4. So negative 1/4. So our axis of symmetry is x is equal to negative 1/4. Am I correct here?
Yes.
Okay. So now to find the vertex. We know that our axis of symmetry is at negative 1/4. So we want to know, we know that our vertex falls on that x point, but what y point? Well, we don't know, but we can find out by plugging in that x value. So once again, for the vertex, we're looking for negative 1/4 comma question mark. So let's plug that in. Every single one of you need to practice typing it into your calculator. So this is what it should look like. 2 times negative 1/4 squared plus parentheses negative 1/4 times, oh no, nothing times there, minus 14. This is how you should type it into your calculator. So I want to see you all typing it in. You should have got negative 14.125. Did you all get that? Okay, awesome. So our vertex is at negative 1/4 comma negative 14.125. Now with these, I'll let you do decimals, because really decimals are easier to graph. If I did ask you to graph, which I'm not asking you to graph, but decimals are easier to graph than fractions. In fact, if I have a fraction, I always change it to a decimal so I can see where to graph it. Now keep in mind, on an end-of-level test, they might, like let's say it was multiple choice, which most end-of-level tests aren't, couldn't you change it back to a fraction? Math, enter, enter, right? Right? Does everybody see what I'm saying there? Okay. So if you changed it back to a fraction, you would have got negative 1/4 comma negative 113 over 8. So that's why decimals are prettier. That's a lot harder to graph than negative 14, right? Okay, so everybody get where I'm coming from. Does it feel a little bit easier today because you were lost yesterday? Okay, so I need you to do the worksheet for a second. Ready, set, go. Example of a story problem. Guys, you have to be able to do the story problems. They're no harder than anything else we've done. Just think about it. Here we go. So it says, during halftime of a basketball game, a slingshot. Do you need an example of the real world problem?
Yes.
Okay, then everybody's listening. During halftime of a basketball game, a slingshot launches a t-shirt at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught at 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is the maximum height? What is the range of the function that models the height of the t-shirt over time? So it says, it gives you the function h is equal to negative 16t squared plus 72t plus 5. Give the t-shirt's height in feet. So it gives us the function. So let's think about it. In the real world, if this slingshot of a t-shirt goes up, it's coming back down. Boom. Do you see how it's, like, let's say it lands in that person's hand. Do you see how that's making a quadratic shape?
Yes.
Okay, so can't we find the maximum height? Isn't that going to be our maximum height? Isn't that the vertex? If that's our equation, isn't it easy to find the vertex? So we have negative 16t squared plus 72t plus 5. So to find the vertex, the highest point, we use the formula. X is equal to the opposite of b over 2a. So the opposite of 72 over 2 times negative 16. Do you see how I'm just finding the vertex, everybody? So negative 72 divided by parentheses 2 times negative 16, close your parentheses. You get 2.5. 2.25. So that's our x point. That's not how high up. Remember, that's our x. So this is x, this is y, right? Everybody? X, y. So it takes it 2.25 seconds to reach its maximum height. Well, we want to know how high. So we plug in at 2.25, how high is our function? So you're plugging it in. Negative 16 times 2.25 squared plus 72 times 2.25 and then plus 5. So I'm going to calculate that. Times 2.25 plus 5. So it's 86. So we have got 2.25 comma 86. You guys all know how I'm getting this, right? So it's up at 86 feet. So I answered the question. It says, what is its maximum height? 86 feet. It says, how long will it take the t-shirt to reach its maximum height? Well, 2.25 seconds. Does everybody understand that? It reaches a height of 86 feet. Is everybody good? And then it says, what is the range of the function that models the height of the t-shirt over time? So remember, range is y values. The lowest point to the highest point. What's the lowest point the shirt is from the ground? 5. And it reaches a height of 86. So our range is between 5 and 86. So 5 feet to 86 feet. So do you see how the real world ones aren't even that hard? We're not graphing. In fact, they're kind of easier. Are we all good with that? Okay, so you should be able to finish the front page of the worksheet. It's due Monday.